Hi everyone, in this video I'm working through question 15 part C of the 2020 Extension 2 trial exam from North Sydney Girls. So it's a two-part vector question, and as normal I'll work through each part in a separate video. The background to the question says, consider 2 points, capital A and capital B, whose position vectors are lowercase a and lowercase b vector respectively. We're told the angle bisector of angle AOB meets the line AB at the point X, and then we're given this diagram here. So part 1 wants us to explain why the vector OX can be written as lambda times A hat vector plus B hat vector, where A and B hat vector are the corresponding unit vectors for A and B vector. So yeah, let's take a look. So I've written out what we're trying to explain, and I think a key piece of information that I've noted here is that the angle bisector of angle AOB meets the line AB at X. I think that's going to prove quite useful. But I think before I recreate the diagram, I actually think it's more helpful if we focus on the A and B hat vectors, since what we're trying to show involves A and B hat vector, so the unit vectors as opposed to the original vectors. So what I might do is, if I just start with kind of picking a point for O, what I can do is I can draw A hat vector as just being in the same direction as what A vector would be, but just having a length of 1. Essentially it's the unit vector. So we'll call that A hat vector, and I'll also draw B hat vector with the same length but just in the direction of the vector B. So this vector here I'll call B hat vector, and the first thing we can note about both of these is we know they must have the same length because they're both unit vectors. They both effectively have a magnitude of 1. Now, I think what's also helpful is if I complete the parallelogram. So if I draw B hat vector up here, so same direction, same length, just starting from a different point. So that will be B hat vector also. And then when I connect these two, I've essentially got another A hat vector because it's the same length and the same direction, just starting from a different point. So this is also A hat vector. And so we can also note that, that these are also the same length, the length of 1. So in completing that parallelogram, we actually get a rhombus because it's a parallelogram with all equal sides. So to help refer to things, I might just define these points. So we can't really use A, B, or X, so I might just continue with the alphabet. So if we go O, P, Q, R. So the first thing we can note is that O, P, Q, R is a rhombus. And that's because it's got all sides equal and the opposite sides are parallel. Okay, now it's also worth noting that if I draw this diagonal from O to Q, that diagonal will bisect this angle. It actually bisects both angles, but in this question we're mainly concerned with this angle being bisected, angle POR, because that's going to link up very nicely with this statement here that I mentioned before, being the angle bisector of AOB meeting the line AB at X. We're going to see how that's all linked. So what we can say is we can say OQ bisects angle POR, and the reason for that is diagonals of a rhombus. You'll often see this written as just bisect the angles, or sometimes it might be written as bisect the angles at the vertex or vertices. depending on whether you're pointing out both or just one. Here we're really just focusing on the vertex at O, and so this diagonal bisects the angles at that vertex. That's the key point. And I think from here now it makes sense to finish off the diagram. So I might just pick a different color. And noting that a hat vector is just a unit vector for A, if we keep extending in the same direction, we can get to point A. And then if we do the same thing for this B hat vector, if we keep extending in the same direction, we can get to point B. And then we can connect those two lines to get the line AB. And that's now where this point becomes relevant, because the angle bisector of angle AOB, which happens to be the same angle as POR, since OA is just an extension of OP and OB is an extension of OR, this angle bisector will continue. So what we've already got in OQ, which bisects the angle, if we extend that to the line AB, then that point is what is defined as X. So what we can observe from drawing the diagram in this way is we can note that the vector OX lies on the same line as the vector OQ. And when we have a situation where we've got two vectors on the same line, we can state their relationship by kind of creating a variable. In this case, it's going to be lambda, simply because that's the letter that we're told to use. So we can actually say, maybe we can first state that the vector OX can be written as some lambda of the vector OQ. And that's basically how we can state the two vectors lie on the same line. In our case, lambda will be, you know, some number greater than 1, really, because OX is longer than OQ. So lambda must be greater than 1 to achieve that. But it's actually not super relevant, the value of lambda. That's not really what we're working towards, but it's you know, might be helpful just to note that. But what we can do now is work out, well, what's vector OQ? So we can say vector OQ. To get to OQ, we can go to OP and then go to PQ. So that's vector OP plus vector PQ. And a good check to make sure you don't mess that up when you're linking vectors is if you cover the middle, you can see OQ, OQ. So that all looks okay. So now we can insert, well, what is OP vector? That's our A hat vector. And what's PQ? That's our B hat vector. And that is as required. Boom! So that's how you can tackle this first part. I think it's only worth 1 mark, which I guess makes sense. I think there's not a lot to this question. It's just really the key is kind of grappling with the fact we're dealing with the unit vectors here. So it kind of makes sense to start your diagram there and end up with this rhombus and being able to make this conclusion about the diagonals of a rhombus bisecting the vertex, the angle at the vertex. So hopefully that made sense. Hopefully you followed along with that and that's all clear. So what I'll do in the next video is I'll work on part 2 of this question. All right, tick boom.